Alright, in problem number 4 we have a rectangle, and we're told that that rectangle is increased by 20% in its length and by 50% in its width. And the question asks, by what percentage is the area increased? Alright, well, let's just start by drawing a picture. Alright, let's draw a rectangle that has a length and a width. Alright, we'll call this the length. I'll just call it that x, and I'll call the width y. Alright, and the length is increased by 20%, so we're going to add some bit on here. And the we're calling this the width. The width's increased by 50%. Okay, so that means that, here's half of the length y, so we're adding half again, so it'd probably look like that. Okay, so we're adding some width and some length. Oops, don't want to go too far here. Ew, that's kind of ugly. Let me see if I can draw that a little nicer. Alright, so let's see. Alright, so we're going to increase the width and the length, and it'll look something like this when we're all done, right? And so essentially we're trying to find what percentage of this original area is this area, this new area, okay? So here we've added 20% of x. So 20% is the same thing as writing 20 over 100, which is the same as 2/10, which is equal to 1/5. Okay, so I'm just going to actually write this as 1/5 x is the width here. And 50%, of course, is just a half, so I'm going to write this as 1/2 y. Okay, that's the increase there. So, well, one way we could do it is just sort of break this up into regions, right? We could do this. Now, we know that the area of this is x times y, right? Length times width. And then we have another rectangle here. Now, the length of it is still x, but now the length of this, or the width of this rectangle is 1/2 times y, okay? And then here, we have this rectangle here. This area is 1/5 x, and the width is still y. And then we have this little rectangle here, and it is 1/5 x times 1/2 y. Okay? So let's add that all up, the increase in area. Okay, just the increase in area is what we're interested in, and then we'll compare it to the original area. So we have 1/5 xy plus, I'm going to multiply these together, we got 1/5 times 1/2, so that's 1/10. 1/10 xy plus, and here we have 1/2 xy. And if we add those all up, now I can put these all in the same denominator. If I make this 10, then this would be 2, right? 2/10. If I make this 10, then this is 5, so it's 5/10. So we have 2/10, 1/10, and 5/10, and that gives us 8/10 xy. Okay? That is the area of this new area, and we're asked what is the percentage, by what percentage is the area increased? So we just need to take the new area over the old area, which is xy, okay? And so the xy's will cancel, and we get 8/10, okay? So this new area, if I were to shade this in, is 80% of the original area, okay? So that because that's the same thing as 80 over 100, which is 80%. Oops, better write that nicely for you. Alright. 80%, right? Okay. And that's the answer. The area was increased by 80%. Okay, because we're looking for the increase in area. We're not looking for, now one way is that if you were to add this all up, you might get 180. So the total area, if you take the whole thing, that total area is 180% of what it was before, but the amount that it increased was just 80%. Okay, so that's your answer.